Hey there, guys, and welcome to the next design stream. Design stream. There we go. This is I've shown this on stream before. This is an LED light that I've had sitting around from other projects and that I used to use, and we will be putting this above my monitors to get better lighting on this desktop. So that's the point of today's live stream. And yeah, not much more else to say, I guess. So basically, I've got this hookup here from the previous project. I think I will reuse this. I was talking last time about finding the AC adapters for this and just doing that. But I'm very much tempted because I've wanted to get dedicated power supplies on my desk. A 12 volt and a 5 volt power supply on my desk. Since I'm going to have the 12 volt anyway, these run off of 7.4 max. And one of those things don't necessarily need to run at the 7.4, but one way or another it can't run at 12, and it's not very good at 5 volts. I tested it with my power supply, my benchtop power supply. So one of those things, if I'm going to reduce it off of 12 volts anyway, then may as well run it at 7.4. And so long as I don't run it at max, it's actually relatively low amperage. At max, if I have it all the way up in brightness, it jumps all the way up to 1.6, but if I bring it down even just a little bit, it's below 1 already. So one of those things, I'm just bringing this up because if I put a buck converter, let's say, on it, it will be able to handle the amperage on that. So that's the plan for the moment. Again, I may change course and just find the AC adapters, figure out wherever those went, and use those, but I kind of would prefer to have fewer wall warts just sitting around and just have this wired up with these spade connectors that I already have here. And that's it for right now. We'll hop over to Fusion and I'll just show you the other stuff that's going on, and you'll have seen this in the thumbnail. So this is what I already have attached to my monitor. This is a little carriage is what I call it, to hold my speaker. So my speaker goes in an L shape right here. The back end is held right there inside that carriage, and that sticks out. You can imagine the monitor being right here, so it sticks out to the side of my monitor. This piece of metal here, this is an 1/8 inch flat stock, 1 inch by 1/8 inch flat stock that I just got from work, and there's a hole goes in this end, and then it mounts to this monitor mounts that I have my monitors mounted to, and that happens on both sides, left and right hand side, just mirrored over, easy peasy. And that's what I want to attach to. I'm avoiding attaching anything to the monitors just because A, that's a little bit more complicated, B, I don't particularly like things hanging on the monitors because it's just, a plastic bevel, so things can happen, and C, this just seems to make more sense to me. So this is the setup we're going for. We're going to go ahead and use this piece that I already have built in here. This height right here is not accurate, and basically what will happen is I'll figure out the height I need, and I'm going to put a piece of flat stock going up and down, but we will be designing that right now. Oh, also, the last thing I will mention is this model right here is actually one I made for the other project, and it was a bit interesting how I had to go about bringing it into this project, because back when I did the other project, I was not very good at Fusion, so this was all just straight up timeline, and this was actually across 2 files. So I had this and this as just timeline bodies, no components, so it made it really difficult to extract them. Well, not really difficult. Basically what I did is I made sure that all the links were broken for anything going in, because I actually brought other things into what I was designing here. I made sure those were broken, and then I inserted it into this file. And when I inserted it into this file, because this file is in a different project folder, that broke everything and turned them straight into timeline objects. As you see here, well, what you see here is actually the second part. So I did that in another file. So I brought in the top part here. This is the top part. And then I brought in the other part into the same file. And then once those were in the same file, I made them into components, as you can see, and then went from there, and then I saved it. And then again, when I inserted it into this one, because this was yet another project file, or project directory I should say, at that point then it again just went and turned everything back into timelines, but at least at this point, the two pieces are their own individual components, which is the most important thing. Originally, when I designed this up, had I understood how components work, that's how it should have been. But regardless, this is where we're at now, so everything is working, and I am happy with that. And that's how you get things into their own components, in case you were a little bit, in case you had a similar situation where you have a body that you modeled up all by itself. Well, take that body, insert it into another project directory, save that. That's going to be a component, and then you can bring that as a component into another project, or just use it as a component in that project to begin with. So that is how that works. And as I mentioned, the height here doesn't matter. I'm just going to cut whatever piece. So I'm just going to start modeling from here. Now for this, and actually I didn't, so our camera mount for the top of the monitor, I'm going to do a similar thing here. I'm going to go ahead, and what we're going to do, actually, I'll get to that when I get to that. I'm going to go ahead and just start designing down here the piece that's going to connect my two pieces of flat stock. It's going to be very similar to what you see right here. It's going to hoop around here, and then instead of dropping down, it will just go up to hold the other piece of flat stock. That's my plan here. So we'll just start with that, and then as I get to other stuff, I'll explain my other thought processes. So, new component. And flat stock connector, I guess. Joint would be better, I guess. So we will go ahead and, I guess, set a midplane here for future reference, and I'm going to back out just so that that's on the top page, just to have something to build off of, or to reference, rather, I should say. And I will design it from this side since I'm hooping around this flat stock. Okay, that was funny. So when you look at this right, I see the square and I got a bit confused, but okay. It is still this flat part is what we're looking at. And I should back up because I made a mistake already. Nice. I gotta come back in here and do the component. Here we go. Project. There's that. And then again, this is just going to be a very simple hoop right here. Just going to offset this, and one of those things, because it's an offset, I guess I will just use the offset tool because I'm not planning on doing anything fancy with this. So just -3, just a 3mm wall, and we'll go ahead and define that right now because this is one of those projects where I can just go with 3mm everywhere. Wall thickness. The other projects like the pallet table, I didn't set that because I wasn't sure if I was going to do 3mm everywhere, but, or 6mm in that case. I wasn't sure if I was going to do 6mm everywhere. This one is definitely just going to be 3mm walls. And there we go. And I will go ahead and symmetric this guy out to keep everything on center. And we can make this so it's 1 inch wide, plus the wall thickness, right, is the piece that's going to be up and down, the flat stock going perpendicular to this guy. So that's how I'm going to model this out. So, and let's see, actually, one of those things, I don't know if this guy, let's see, would it be in here? Monitor stand. I don't think I brought components over, or when I derived this guy, rather, I meant to say. When I derived this guy, edit. Darn, it's not letting me edit. Did I just insert this? Did I not derive? Okay, I did just insert it, that's why. Okay, I was gonna say, when I thought I derived it, but I guess I inserted it. So, I was hoping to be able to get the flat stock parameters in here, but I guess not. Okay. Back to where we were. So this is going to extrude out. Symmetric. So flat stock's 1 inch, and then wall distance type 2, or thickness type 2 for each side. And that should be good. Now we can come up here on top, set a reference plane, and we'll draw our flat stock in, project that guy, and let's go ahead and turn the LED light off for the time being. And we don't really need this monitor stand either. And the bodies will be off for just a second. So a couple things here. Technically speaking, I should be able to just wall thickness around this, and it should be the exact dimensions. So if I do that, and then I'm going to dimension this just to double check, because I set this up as already being, yeah, so it's 25.4, so that's an inch right there, and then this should be 1/8 of an inch right here. So calculator, grab my calculator really quick. 25.4 divided by 8 is 3.175. Yep. So yeah, that's one way to do it, because I knew that I already took into account the wall thickness. And just because that's simple, we may just keep with that. So I'm going to go ahead and just extrude this up. And one of those things, the distance that we want is a little bit arbitrary, but I'm going to go an inch. It's a little bit arbitrary insofar as it depends how much we want for leeway. Or not leeway, support. I'm thinking leeway because I'm about to go ahead and come in here. And one of those things, because of the dimension, or the way this is going to be printed, as you can see, all my planes are perpendicular to each other, so there's not a good way in this case to print this. So I'm going to go 0.1 instead of my normal 0.05, because one or two, well, probably one of these walls is going to be a bit off. And actually, I should also do the bottom one, because I'm not sure what orientation just yet I'm going to be printing in. A couple ways that make sense. So printing it in this orientation does not make sense, because we have an overhang here and an overhang here on this side, so that's actually less than ideal. The other ways to print it right up and down like this, right? We have an overhang in the bottom here, which is not that big of a deal, because the flat stock doesn't need to be perfectly flat against the bottom there. And then an overhang on here, so that's just effectively one overhang, because again, the one on the bottom doesn't matter, so that's okay. If we print it like this in this orientation, and I'm just gonna pivot us a little bit. Let's pivot up to this corner here, isometric view. So in this orientation, we have no overhangs right here, and then just an overhang on this side a little bit. So this may be the direction I'm going to end up printing it in, just because that's the smallest overhang right there, right? You see that's overhang is only this 1/8 of an inch right here, and everything else is fine. So that's probably how we're going to print it. But otherwise, for the rest of it, I don't think we need any fastening instruments here. So for example, you will recall on the camera mount, if you watch that one, I put a screw in the backhand side to tighten it down to the monitor. This one, I don't really see the need of doing that. So, because I don't expect this sliding around. And if you look at the speaker carriage over here, I didn't do it over here either, and my speaker carriage has not fallen off this flat stock yet, so I feel very comfortable just leaving it floating there and having it not move. So that is actually done at this point. That is a very simple piece. Don't need to overcomplicate things. We will just do that, and again, it will probably be printed. I'm just going to use the cube to get us there. And I guess it's that. Nope, that one. I'll figure this one out. Anyway, you saw how I was going to print it. And this, yeah, orbiting is a pain in the butt. Right there, and then rotate to right. Whoops, no, I want this corner. There, and that corner, that corner. There we go. Printed like this. Camera view, a little bit difficult, but this gives me the smallest overhang just on this side. And that's the only overhang, so probably going to be printed in this orientation, like I said before. So let's hop back up to the main component, and we can go ahead and, not that guy, this guy. I'm going to go ahead and throw a joint in now and add some color to differentiate. So let's grab yellow because I haven't used yellow yet. Yellow matte. And we will just go ahead and as built joint. This is going to be effectively rigid. I'm not expecting it to slide on and off. I could call it a slider, and that way I can demonstrate it sliding onto the end here. But I feel a little unnecessary at this point. So I'm going to go ahead and new component, vertical flat stock. Okay. We're going to go ahead and take the inside of this guy. And again, this is just for the stream. I'm just modeling this up for the stream. I will take actual dimensions myself and cut the flat stock to exactly what I need. So I won't be going off of this CAD here for this flat stock. I will take real life measurements. And technically speaking, because I already offset that guy, this is not actually 1 by 1/8 right here. So I will go ahead and actually draw it in and just turn off some of these bodies first. Draw our square, get our center line just like always, and center everything up. And then we can go ahead and dimension it out. And actually this did not mean to go there. I meant to go here. Also, for the record, as I'm doing this, I had this genius, and I mean absolutely genius, that anybody could possibly see, you know, someone else, and what I'm trying to say, probably thought of this before me and has just not told me on stream because they didn't want to embarrass me, because it is that obvious. But I've been mixing just off of, so if you, sorry to interrupt here. I know that looked like that was right on line, but when you zoom in here, that's our 0.1 millimeter right there. So that's why that is like that. But anyway, the idea that I probably should have had a long time ago, and just plain did not, is I've been adjusting the audio off of 2 sliders in my streaming setup software. And it occurred to me this morning, or last night, and no, it was this morning. It was definitely this morning. It occurred to me this morning that that was probably not the right way to do it. Instead, I should probably actually be doing it through the Windows Mixer, because the problem that I was running into was that I only have 2 dials, one for my mic and one for the system volume, which means that if I put the so for example, Mustache on my slider, to get Mustache to where I really needed it, I needed to bring that like practically down to 10%, which was really difficult, and the difference between 12% and 5% was huge. Whereas in the Windows mixer, I can set different things at different volumes, and it makes my life a whole lot easier. So that's the deal. So next time we stream Mustache, which is probably going to be this afternoon, because it occurred to me that the that I'm probably, my biggest problem yesterday was probably just that I'm out of practice. Wow, okay, I should probably move this up a little bit more. And that if I just played it a little bit more consistently, because it was a whole entire week since the last time I played it, then we probably don't have this situation where it takes me an hour to get back into the swing of things before we're finally there we go, before we're finally actually doing decent at the game. So I'm gonna put in some more time, and then today, and then maybe a little bit more in the middle of the week, just so that we can keep on top of it, so that I'm not going back to square one when we start. And this is actually, I'm gonna go a little bit higher with this guy. Again, these numbers right here are just arbitrary. I just don't want to I want to have space in the CAD in order to add the extra stuff. So for example, if I added 1 inch right here at the top, this would be all smushed together and it wouldn't look good. So that's why I'm just lifting these up right here. So let's go ahead and add the monitor and flat stock mount. Now this one I actually should have measured before we started, and it didn't occur. I guess I can get a rough measurement. So basically here, my this carriage right here is a certain amount from the monitor. The front of the monitor is right here, or the back of the monitor is right here, I should say. I don't know what that actually is, because it doesn't matter for me. My speaker is just barely set back, so it wasn't that big of a deal. I didn't have to try to readjust everything. I probably bent this at a specific length to get me right there for the speaker, but that's going to be different for the light. So because that's going to be different for the light, I'm going to really quick take a quick measurement to see how far our light probably needs to move, and then we will make adjustments from there. Sorry, sit forward in order to be over top the monitor instead of behind the monitor. So 12 millimeters plus 23 is 35 plus 57. All right, so if I call it 60, if I say we got to clear 60 millimeters, that will get us a little bit of extra room, which is all I'm looking for, and we can make everything adjustable to compensate. So that's what we're going to do. We're going to go ahead and design this top part so that everything can move, and then we should be good. Again, 60 will be my minimum, well, my maximum rather. 60 will be my maximum, and then we will go from there. So, there's gonna need to be a couple different things built into this at this point then. My original idea here was to use this bottom base piece, so I could just print another piece for this to mount onto, so long as I was absolutely sure the LEDs were going to be where I wanted them to be. Then this could just actually be a custom piece. This bottom piece right here could just be a custom piece built into this stand. Instead, because I wasn't 100% sure, I will use this, and then this will slot in and slide back and forth and be able to be tightened down using this ring in position. Now, also, in order to make sure we actually latch onto the monitor like this, I'm also going to need the plastic intermediary part that this will be sliding in to also itself slide on this flat stock right here. So we've got a few different things to design. And actually, let me go ahead and really quick, I think I'm going to actually undo this joint right here, and we're going to make a rigid group. I'm going to turn off child components just in case, and we'll go ahead and grab all these guys, and we'll just add to this rigid group when we add the next piece that needs to be built, which we're doing right now. So this component actually will have child groups, which is a good reason why I turned off include subcomponents. It makes more sense, since this is all piecing together, for it to all be like it's plastic to plastic piecing together is what I mean. So it makes sense to me that it's all in its same component, although you can make the argument that it should just be top level components like the rest of this. Again, that's an argument to be made, but I'm going to disagree for the moment. So let us go ahead and what am I going to call this? Top joint? I'll just call this top joint. It's one of those things, right? I come up with names like break on the pallet table. I kept on calling everything a bracket. Today, everything's going to be a joint. 420. All right. Sorry for the vacuum if you can hear that. Last I checked, nobody was home, but evidently somebody's home now. So we're going to toss that on there. Toss this on here. Get ourselves centered up. Whoops, and Fusion did that funny thing again where it does extra lines. Get these guys centered up. And actually, you know what? I've been doing this for all the other things. May as well stay consistent, right? Wall thickness right here. There we go. So we will... Do I want to draw the rest out right now? Yeah, I want to draw the rest out right now. And now... And I didn't actually have to delete all that stuff, I guess. Let's see. So this, what am I envisioning this as being? Do I want to do a dovetail? I guess I can do a dovetail. And in that case, do I even need to draw it right here, or do I draw it face on? That is a good question. Yeah, I guess I just draw his face on, so we will just go with this for right now. Down 1 inch. And then we'll take off the top here. And actually, because I didn't create this body in its own component, I guess I'll go back on what I was saying. And maybe I should have done top assembly and then top joint as a subcomponent. So I guess that's that. Go off the top here, and technically the top here is the same as that construction plane right there. Top of flat stock, and we'll just bring that up wall thickness using these sketches right here. Could also use the body, but I prefer to use wall thick. Use the whatchamacallit. And one of these things, I technically don't need to do that, just because, well, yeah, alright, I won't do that. I won't do that for the reason that I'm going to want to do this, this dovetail anyway. Now, the biggest question is, this dovetail is only, we might want to redesign this a little bit, because the dovetail, if I do it in this orientation, is only going to be 1/8 of an inch thick, plus 6 millimeters. So I guess that gets us up to 1/2 inch thick. That's still not very thick. I'd want it more like 1 inch minimum. Yeah, 1 inch is probably fine. So in that case, one of those things, 1.5 million ways to design something. We could have designed it all on side, or on face rather, taking the mid plane here, and then extruded it out, and then use the join command to cut this out. That was definitely a possibility. I guess we'll do it this way at this point. And I wish you couldn't click and drag stuff. I have no idea why Fusion allows that. It does not make any sense at all to me. And I'm just hopping in here for this mid plane because this is where it really belongs, along with this top of flat stock plane. Both of these should have been in the other one. I just didn't. So one of those things. I will correct myself now and not worry about the other one. So let us, whoops, I was trying to open up that guy. And just to rename this one, this is the Y midplane. Okey-dokies. We'll project this guy out. And then we'll draw a quick dovetail. Boom, boom, boom. And these guys will be 45s. Not 40, the other way. I'll do it like this. That way I can use 45 instead of 135. And this guy will be equal to that guy. And then we just got to decide on the height of this. So the height of this, I guess, will be 0.5 inch. I mean, how big does it really need to be? It really depends on how girthy we want it. It doesn't have to really be that big. Again, it's a bit of a personal preference. I'm just going to go 10 millimeters and be done with it. I'm going to symmetric this guy out. Whole width 1 inch, rather. 1 inch. And then, so there's a couple different ways we can do this. Like I said, an interesting way, actually, now that I'm thinking about it, just to beef this up is all I'm thinking about, because technically speaking, we can print it like this, and it will be absolutely fine. It will print no problem. But I wanted to add some more meat to it, because it will be, stuff will be sliding on this, right? And therefore it may need a little bit of extra support, a little extra meat to it. The way I'm going to do this, I think, is actually draft for funsies. And it's going to want to go this to this. Draft is kind of funny because it's always a little counterintuitive how you got to go about this. So if I go the other direction, you see how it does that, right? Which is why I went the other direction to begin with. This one to this one. There we go. That's what I was looking for. Yeah, I like how that looks. Again, it's going to be printed in this orientation, so I don't have to worry about overhangs or anything like that. So we will go ahead and go with that one. features, wrong feature, that one, and then our mid-plane that we just made, and there we go. So there is that, and that should be everything. So I'm gonna go ahead and start drawing the other guy. And again, because I did this in this direction, actually before we do that, Control Z, let's go ahead and open this guy up. Minus point, actually this guy we can do 0.05 because I'm not worried about overhangs here. So come back up here now, add a little bit of color to our world. Plastic, I guess we'll do purple. Cool. And then we will go ahead and create a new component. Try to create a new component and then fail. And this will be monitor slide, I guess I'll call it. And boop, boop, boop. Where do we want to start drawing from? I guess we'll draw from the... See, so I need 60 millimeter. Yeah, I think I'm going to draw from the side on this guy. And actually, it occurs to me, this really depends on how we want to do this. Yeah, okay, this is how I'm going to do it. Because we're going to have to, again, I wanted to have something to tighten down here, to tighten it to make sure this doesn't slide. I guess it's not completely necessary. It's not completely necessary, so I'll come back and add it if necessary, but it's not necessary at the moment, and therefore we will not add it just yet. I was just thinking where I wanted to put the nut and bolt, because I wanted the bolt head to be flush in the bottom of this, in what I'm about to draw. And top of joint, okay. Oh shoot, I didn't want top of joint actually. I take it back, Alright, do I have a mid-plane left right here? Let me hop up here so that it's easier to see other things. That guy, or not that guy, that guy. Okay, there's that. Oh yeah, that's right. I have this mid-plane up here. And that is the X mid-plane. Okay. So we're going to open that up. Whoops, don't open that up here though. Get into component and then open that up. This is the direction I wanted to draw it in. So we're going to go ahead, and if I wanted to throw the bolt in, I'd have to compensate for that right here. The nut here, and then the bolt head up on top here. That's how I was going to design it, but I don't think it's really necessary to tighten it down at this point. Again, we'll see if I have to change my mind here, but my total slide here is a minimum of 60, so I'm going to go ahead and... How do I want to draw this? Because like our camera mount, I'm going to go ahead and put a lip on this side. So I guess I'll do the 60 like this. The alternative was to go like this and put this out here and then do a 60 on this one. It doesn't necessarily matter which I do, I don't think. So we're going to go ahead and do the former. And I'm just doing this to get those guys lined up because, again, I don't like using coincidences on squares because it's really hard to track down which coincidence is which because each corner already has coincidinkies. This wall thickness will just be our standard wall thickness right here. This is the lip in front of the monitor. And this guy, we're going to have to figure out what he's... we don't necessarily need to figure out what he's going to be right now. So we can leave him at wall. We can always add on to him for the stuff above. Right now, he's going to just be whatever he needs to be. And then we're going to coincide him here. And we will have him all the way at the forward position for right now. So I'm going to go ahead and collinear that side. Let's turn this into construction lines. And then, so this is the main structure. This lip right here, from here to here, let's see. I guess I just measured my, whoops, Sorry about that. I guess I just measured my bevel last time. Let's see what the bevel looks like. Okay, so I'm going to call that 6 millimeters. It's a little over 6 millimeters, nearly 7, but I don't actually want to overhang the screen at all, right? So we're just going to call that 6 millimeters. And then, why are you guys moving? What is not constrained here? Fascinating question. Because this is collinear here. Because this is collinear here, and this height is set, this shouldn't really move. That's 3 millimeters. That's collinear here. So yeah, the vertical should not be blue right now, I don't think. I wonder what part of it is unconstrained. That is very interesting, because everything's collinear and square. Alright, well, I don't think there's any... Let me just do this really quick. Yeah, see, it says it can't actually be dimensioned. So since it can't be dimensioned, the only thing it could possibly be is angle, but all of these are set horizontal vertical, and therefore that can't be an angle because they're all in the same plane. So I actually do not know why these guys are blue right now. Regardless, not actually important for us. Last thing I will do here, whoops, is we will draw in the rest of this slide, and actually, oh, I know what is not constrained. I never actually came back in here and dimensioned this 60. And what I was going to say is this actually needs to be 60 plus the thickness of my monitor. So, actually no, that's right. The thickness included the thickness of my monitor. The 60 included the thickness of my monitor. So 60 should be fine in that case. And actually I can even go up to 75 just to be extra certain, because again, this can stick out the back, no problem. So that is what we will do. And now, this right here is the other thing I was thinking about. So the gap between where the dovetail ends and where the monitor sits, we're going to need some of that, because again, the 60 takes up the thickness of my monitor, and I believe this was about 22 is what I recall, and I somehow ended up in human units instead of computer units. So let me swap that back on the calipers. Okay, that's reading more like in full inch right now, so I'm just going to go ahead and call that I'm going to call that 35 millimeters, I guess. These guys we can go ahead and quinky-dink like this. So that's going to be there. That's going to be there. And this is going to have to quinky-dink here. And this will be our dovetail slide area. Now, I added an extra. I had counted 60, right? And then I added 15. Yeah, I guess we'll be alright. It doesn't have to travel that much. My measurement, the only travel we need in here is if my measurements is off, and I don't imagine my measurements are off by a full inch. So we're probably alright with that degree of adjustment. So let's go ahead and symmetric this guy out. Symmetric out. And actually, this is not going to be symmetric. This is going to be two-sided, because what I want to do is 2 objects on each side plus an offset. And it looks like that's going to be a bit difficult the way I'm set up right now. So let us back up just a second. Come back up here to top joint. And we'll go ahead and put planes at angles here. This is top of joint for the record. And we can turn that off because we don't actually need it right now. And we will plane at angles these guys, 90, to give us some tangent planes to work off with. And then we can go ahead and left side of dovetail, reference these guys in our extrusion. Right side of dovetail. I actually don't need both of these, so I will actually delete the, well, Control Y, delete this guy, because we can symmetric it off. So we will go ahead and do that. Let's hop back up here to monitor. All these profiles, distance to object. That guy, yep, that looks like it works. And then wall thickness on the offset. Now I can either symmetric this now or symmetric this later. I'm going to go ahead and symmetric this now. And then just cut the dovetail afterwards as one piece. I could do this mirror feature after the half the dovetail is in. And why did that not? Huh. Two bodies. What plane am I on? Oh, I know it's why. I know. So it's doing this. I'm gonna have to delete this. It's doing this because it's adjust, and therefore it looks at the extrusion that I made here. It looks at this extrusion and said, oh, he wants to move towards that. So if we're mirroring it, we're going to mirror off this plane towards that plane. That's why it's doing that. But that's not what we want. So we're going to change this. Optimize might still give me two bodies. Yeah, okay, optimize still gives me two bodies. You know what? Forget it, it's fine. We're just going to join these guys. Actually, because I'm going through all this effort, nah, we'll join these guys, and then I was going to say maybe I just cut the dovetail first, but forget it. So we'll come to the back here, back of slide, plane, back of slide, and we'll go ahead and then just project out that dovetail, and then we can just cut that to the front, leaving a wall thickness worth as the offset like we did before. Actually, yeah, technically speaking, we can cut all the way through, just because it's just as likely to slide off the front as it is off the back. So if I'm not going to, trap this in here somehow and stop it from sliding out the back, there's actually no justification as to why I need to add a wall in front here. So I won't. So that is that. So this guy slides back and forth on that guy to get us, make sure that we're on the front of the monitor. And again, if I want to, I can throw a bolt in here just to fasten it in place. But I don't think that's necessary. The only reason it would be necessary is if I'm constantly moving my LEDs around, this LED thing around. In which case, as I move this, this is probably going to also want to slide. But it's not that big of a deal, and I shouldn't have to move this around. I should be able to get this in place, and all this is just so I don't have to print extra pieces, making sure everything, extra plastic pieces, making sure everything lines up correctly before I do a final print. So that is where we're at right now. I'm going to color this really quick, and then we will go ahead and add the slot for this guy. So I'm going to go ahead and modify, align this guy on the center of this guy, flip him over and spin him so he's facing front, and capture position. And now we'll be able to build the slide for this guy around. I'm half tempted, I won't bother. I was going to say I'm half tempted to put a front plate on here to stop it from sliding off the front, but we've already got this ring on here tightening us down, so we don't actually need that. So we can just go ahead and slide, create the slide for it. Again, using the back plane here, we're going to go ahead and project up. Okay. And then I will also project this guy right here, and now we'll just use that guy, and then we'll just go whatever I feel comfortable with. Actually, I take that back. We need this guy, and we need this center piece as well. Whoops, not that guy though. I'm actually not in project evidently, so we need this and we need that. To make sure that we clear that when we make this slide, because otherwise, let me just draw this in and then you will see what I'm talking about. So if I take this, and this is my slide right here, so this is just going to go like this and be the negative image of everything else. This is the negative image of this stuff in here. If I didn't have this projection right here, it would fill in this area too, which is bad. So I want this projection right here to keep me from filling in that area. And then we can just extrude this out. Very simple. Distance to object. There we go. And join. And now we just want to loosen everything up so that this can slide easily. So we'll come in here with the offsets. And I am still on new offset. Good. That. Whoops. That. Minus 0.05. And actually I'll go 0.1 just to give myself an easier slide. And there is that. So let's go ahead and look at everything all together. We're going to pop forward one and then adjust this rigid group to include that guy. We'll go ahead and look at this. Oh, whoopsies. This was a mistake right here that I did not notice. Objects to cut. We want to make sure we're not cutting the top joint. There we go. Now we can go ahead and add this joint in here between that guy and that guy. Actually, I should do it the other way around because this is the piece that's moving. Let's turn that dovetail slide off, and we want this to be a slider. I'll turn the monitor slide off for a moment just so I can get this guy. And you can see that slides back and forth now. We can set limits if we want, not really necessary. And then we'll go ahead and do the same up here. This is once again another slider. And this is the component that's moving on that guy. And it is on that rail. It could actually be any of these rails, it doesn't necessarily matter. So this guy slides forwards and backwards to get the lip on the front of the monitor. And then this guy right here can slide forward and backwards to give me some play for where the LED is sitting. So for example, if I want to put it right here and then tilt this guy down, so you can imagine the front of the monitor is right here, right? So that's how that is. Or if I bring it all the way to the front, again, top of the monitor is right here. So now when I tilt it down, I go the full 90, or pretty close to the full 90 at any rate, and it's pointing much straighter down. So those are all my options on how this can work. Undo drive joints. And that is this design complete. Again, I wanted to make this flexible so I didn't have to get all my measurements exactly right. I just needed to make sure I gave myself enough leeway. So for example, with this dovetail, give myself some leeway for where it can sit relative to the monitor. There's enough space in here for the monitor to sit. This guy I will get physical measurements for and cut him to size to be correct. And this guy obviously slides left and right to get center on the monitor. I can even not center him on the monitor. Technically speaking, this can be all the way down here if I want him to be. If I want both lights or one of the lights to be more center of the desk. Because fact of the matter is that if we look at my work area, camera, there it is. This, if you're looking at my right hand here, right here, is actually only at the 1/4 mark on my monitor. And this is where most of my work happens. So the light probably wants to be right here, which again is not centered to the monitor. The center of the monitor would actually be all the way over here off screen. On this side, center of the monitor is probably all right, but again, it may be better off more towards the 1/3 mark. And again, the funny thing is that this is relative to where the camera is right now. The camera used to be over to that side a little bit more, so you're actually seeing a different, slightly different part of my desk. So for example, the lift pod over here, which is what I put the camera on when I want a close-up of my desk. That guy is not as much in screen when I had the camera over here because the camera perspective is slightly off. So it's one of the interesting things where the lights need to be also probably should move depending on where I've got the camera. The camera being on this monitor only because I was playing Muse Dash. So that is all that. Again, another successful project. I'm going to go ahead and jinx myself. As far as I can tell, there's nothing really that can screw up. Again, I used this model in another project, so I know already that these dimensions are good on the camera, or not the camera, the light model. So long as my printer doesn't underprint these, and just for the record, because I like talking about keeping in mind how we're going to be printing these things, this guy is actually going to be a little bit difficult. It really wants to be printed like this. This is how it wants to be printed because the dovetails I want to be perpendicular, but I've got the lip in front here, and I've got also this slot on here, which is the other reason why it was to be printed straight up and down here. So this guy might actually give me a little bit of trouble. I may be better off just cutting this front part off. And that's a decision I'll make. I mean, I probably won't, because let's face it, I wanted that lip to be down there to make sure that it stayed, you know, with the monitor. But the fact of the matter is that there's no real reason why it needs to be. So basically, this flat stock right here is literally built into the monitor. So this gets screwed into the pivoting plate that the monitor is on. And therefore, if I move my monitor, and actually I just did that, and there's literally no way for you to see it because the camera is on top of the monitor, so I won't be able to show you. I mean, I could take the camera off, but too much hassle. Anyway, the point being is that the flat stock is fixed relative to the monitor, so actually having this lip on here is not necessary, and because of the rest of the design, I probably should just take this lip off. This ramp, though, the rest of this length should remain, though, because it should guide the LED light all the way over top of the monitor. So the rest of that will stay, but I will go ahead and just hop in here, figure out where this is at. Let's see. There's the dovetail, so it should be over here. Yeah. I'll go ahead and just delete this guy, and this measurement, this 75, can actually stay how it is. It's just going to be 75 to from here to there, and actually that would be the same thing as 75 here. So that actually says 78, which is interesting because that dimension shouldn't have moved. This was 35, right? Let's Control Z a few times. 35 there to there. Oh no, that's right, because the front of this guy includes the 3mm here. That's why. So, yeah, these can actually, this can be 75. There we go, and that is correct now. So we are going to make that change just for printability purposes. Otherwise, like I said, this piece is the only other, well, these two pieces, this piece we already discussed, and this piece we already discussed how it's printing. So, yep. Everything now looks, again, I was thinking about leaving this guy on, but there's no real sense to it because this whole entire flat stock stays exactly fixed in position relative to the monitor for the lip to be on the front. And that is us done in that case. So I will go ahead and get this printed, get lights up for the next time we do a design stream. I don't think I'm going to leave them on for Muse Dash, because we already got lights on the LEDs, and I'm concerned about lights on the LEDs, lights on the buttons. The buttons have LEDs in them, and I'm concerned that the plastic on the buttons will just reflect the LED light off the top of the monitors and make it look horrible. So we will not have the lights on for when we're playing Muse Dash, because that could really mess things up. Well, make it look horrible, not necessarily mess things up. But otherwise, for future streams, when I come down here and hop the monitor on, we'll have a little better lighting situation down here. Hopefully though, and I'm saying this because, again, I've used these in the past, this does do a real number on the white balance, so we're gonna have to see how that works out. I may have to make some changes. Somewhere around here I should have a red filter for this guy. I believe I have a red filter, which would help the white balance a little bit, but we'll see what happens. We'll cross that bridge when we get there. So, as always, thank you guys for watching. I hope you have a great and wonderful day, afternoon, or evening, wherever you're at in the world, and I will catch you next time.